Future Network webinar, participant to register using link provided in the chat section. Registration is important to qualify you for a course certificate that will be issued by the institute. The webinar will be start at 2:30 p.m. and before that we will watch a video about Attack Malacca.
Malaysia boring, derajat di lain.
Kami suka orang Malaysia.
Pertama, Malaysia sedang.
Malaysia makin maju.
Kami saya Apotek Malacca.
Malaysia bagus. Malaysia apotek Malacca bagus. Kami saya apotek Malacca. Saya Malaysia.
Dat is spinnen.
Saya suka Malaysia. Malaysia boring. Derajat asik lain.
Kami suka orang Malaysia.
Sekarang Malaysia sedang.
Malaysia lagi maju. Kami selalu update mereka. Malaysia. Malaysia. Bagus. Saya update mereka. Malaysia.
Hello.
Assalamualaikum dan salam sejahtera kepada semua peserta. Saya Luciana dan rakan MC saya Kirtana. Kami merupakan pelajar semester akhir ETEK Melaka dalam jurusan Diploma Teknologi Telekomunikasi. Untuk makluman, webinar ini dianjurkan oleh bahagian Telekomunikasi, Pusat Latihan Teknologi Tinggi Melaka, ETEK Melaka. ETEK Melaka merupakan salah satu daripada 33 institusi kemahiran di bawah Jabatan Tenaga Manusia, Kementerian Tenaga Sumber Manusia. Penceramah jemputan pada hari ini ialah Encik C.Y. Wong, Ketua Pegawai Operasi Hot Link Hang dan Encik Liu Bun Yin, Pengurus Pemasaran Arisu. Seperti kita sedia maklum, 5G ialah standard teknologi generasi kelima untuk rangkaian selular jalur lebar. Dalam webinar ini, dua topik akan dibincangkan oleh penceramah-penceramah jemputan. Topik satu adalah prospektif, kejaya dan cabaran 5G di Malaysia. Manakala topik kedua adalah pengujian 5G wireless network dan pengujian peranti mudah alih 5G.
Good afternoon to all the participants. I'm Kitran. Along with my MC, my friend is Luciana. We are the final semester student of ETEK Melaka in Diploma in Technology Telecommunication. For information, the webinar organized by Telecommunication Division Advanced Technology Training Center ETEK Melaka. ETEK Melaka is one of the 33 skill institutes under the Main Power Department, Ministry of Resources. The guest speaker today is Mr. C.Y. Wong, Chief Operating Officer of Hock Lee Heng, and Mr. Liu Wan Yan, Andristu Marketing Manager. As we all know, 5G is fifth generation technology standard for broadband cellular networks. In this webinar, two topics will be discussed by guest speaker. Topic 1 is prospect, career and challenges of 5G in Malaysia, while topic 2 is 5G wireless network testing and 5G mobile device testing.
Untuk topik pertama, kita menjemput Encik C.Y. Wong bagi mengupas tajuk prospektif, kejaya dan cabaran 5G di Malaysia. Untuk makluman semua, beliau merupakan Ketua Pegawai Operasi Syarikat Hot Link Hang dan terlibat secara aktif dalam perniagaan pemasaran communication tower. Dengan tidak membuang masa lagi, saya menjemput panel iaitu Encik C.Y. Wong mengupas topik tersebut.
For the first topic, we will invite Mr. C.Y. Wong to discuss the topic of prospect, careers and challenges of 5G in Malaysia. For everyone's information, he is the Chief Operating Officer of Hock Lee Heng company and is actively involved in communicate tower installation business. Without wasting time, I would like to call Mr. C.Y. Wong to explain more about this topic.
Yeah, good afternoon to everyone in this group. Thank you, ETEK Melaka and Miss Moderator and my teacher, Cikgu Lim. So 3G going to end soon. So 4G now mobile network that's used around the world. So before COVID, Malaysian high usage on this Facebook, YouTube, and all these things. So during COVID-19, Malaysian higher users. So why? Because all work from home. So work from home, nothing to do. Then they do what they call the online business by using Google, Zoom, the e-wallet. Last time people using, but now more people is inside there in the e-wallet. So all the ICT all increase related to all these things. So carrying people through sharing knowledge. So this is because Malaysian is a loving and sharing knowledge society. So therefore, our ICT requirements shoot up fast. But this is not enough. We still need more effort to further to push up and improve our Malaysian ICT users in the business. So when you notice this car, no tire. Okay, this is how long I think this is future is coming lah. When the car no tire, a lot of things business all change already. Not like last time already. So everything changed. Well, anything you had to go to Google and YouTube, you can see a lot of things like that. That's a new technology. So 5G, super fast. 5G is 100 times capacity than 4G. You see, the last time 3G, we download the video for 2 hours. So we need 26 hours. But 4G, we need 6 minutes. Then now 5G, only 3.6 seconds. But then Malaysia, we all focus on this 3G, 4G. Until today, 3G, so the move in 3G more faster. So in these 2 hours, but of course, we don't download movie, we download more on education and useful program. So we look at the 4G, 45 minutes, 45 millisecond response time on the command. 5G, 1 microsecond, very fast. So this is what I call very high frequency and ultra high frequency when in the 2G, 3G, 4G. But now 5G is a super high frequency because by 5G working with the satellite, direct from the satellite to the earth. So 5G self-driving cars cheaper, but the whole Malaysia must complete in the 5G then only we can self-driving car. So when this is when they go to 6, 7, 8G, maybe the name still there but auto fly aeroplane, okay. This is thing we got a lot of things in the what I call in the technology already. So the time is what I call Internet of Things, the mean system to system to communicate to each other. So smartphone, what they call this one is smart home. So you can use a phone to control lighting in the house, aircon before you reach your home and all these things. So all technology by using software and hardware work together. So medical device, so industry equipment. So when industry 5G speed up with this industry revolution 4.0. So we need more grant, development grant to support the SME so that we can grow on this one. So okay, 5G, okay, for agriculture machinery, so there. Virtual tourism, shopping and treasure hunt. You know, treasure hunt with the people you use the Google and the game and all these things. So like example, this one you log in, you want to become like what the survive team, rescue team lah. You see the team that go to rescue the people, they sent to the hospital. After that, he finish his work, then he go round all the way to go and buy food, ordering food. There's a called e-shopping, e-commerce. You buy food, then deliver to the house. This is in future by using the game, working together, many friends in the world. So big data, this is very big big data now. So keep all the data into the data bank for government sector, medical, banking, insurance, and customer. A lot all this related like mobile app and all these things. So a big amount of data being upload and download every second. So we need a very big government and corporate company to work together. Work closely to make it in success in the big data. So career and challenges. So a big challenge for 2021 with the wireless infrastructure technology and the 5G. Look at this one. YouTube and Google and Facebook all related. By the way, see, you have to help yourself to find out what you want to be first. What you want to be first. That's why with the technology, anything you want to know, very easy now. You can go to Google and YouTube to find, what you want to be. But in the learning in career, for me, it's not a challenge. You have to be understand where to find. But the important, you have to remember skill and knowledge first, money in second. If you don't have the skill and knowledge, you're looking for money, that is wrong already. So that's why when you got skill, you got talent, so the people should like you one. That's right. In the YouTube, Google, everything you don't know one, you go inside there, you find everything is there. So you must help yourself. So you can search from YouTube, like example, just now I say, find out what is attitude. Anything you want to know in the YouTube, but not other thing. Only to improve us to get the income for yourself, to build up your family. So for the big corporate, they have to play the role to build more micro SME. Example aircon installer. You have the big system, new product and all these things, any of the product in the big corporate. So they had to build up more SME people outside there. Got the new technology coming in, you teach them, guide them, so that they can can hardworking, do more thing, So sometimes working with the people, sometimes pay only like this, right? So that's right, micro SME for them to you large in, you got the money, but you must with the talent and the skill and the knowledge. If you don't have, it's quite difficult. That's why I say knowledge first, money second. So in the future, remember, in the future, the most important one is service. Why service? Because attitude and the service is very important. But anybody know how to do nasi lemak example lah. Everybody know how to cook. That's why I say your service, clean and everything. This is the first one. In the future, you have to be focused on. So we as a Malaysian, we had to start to plan for the kid 3 year onward. Why? Because now 3 year, the children now, not like last time on. Now you born already, the eye open already. I can see everyone. So that's why like my son, 10 years old. That time I teach him a little bit. He remember until now. That's why now you don't simply give the handphone to the boy or to the son, After that, whatever you see inside there, don't know what you see, but you have to be monitor and all these things. So after 20 year, 2041, you can see the different, the harmony country. That's why we need to focus from now in the 3 years onward. If we don't focus now, then in the future, there will be more people right out there, no skill. That's why I say ICT is very important. So with 5G, we equate Malaysian with the future skill for IL 4.0 and micro SME. Thank you very much.
Terima kasih kepada Encik CY Wong yang sebentar tadi bagi banyak input yang telah dikupaskan oleh Encik CY Wong untuk mengenai perspektif kejayaan dan cabaran 5G di Malaysia.
If anyone have any question, you may be asked.
Thank you. Yes, women.
Terima kasih kepada Encik CY Wong sebentar tadi. Banyak input yang telah dikupaskan oleh Encik CY Wong mengenai perspektif kejayaan dan cabaran 5G Malaysia. Para peserta diminta untuk mengisi borang kaji selidik webinar 5G di ruangan chat dan WhatsApp bagi penambahan baikan untuk masa yang akan datang.
Thank you to Mr. C.Y. Wong just now. Many inputs have been fielded by Mr. C.Y. Wong on prospect, carriers and challenges in 5G in Malaysia. To all the participants, please fill up 5G survivor form in the chat and WhatsApp. Ladies and gentlemen, we break for a while until 3 p.m. until the next section.
Hello?
Untuk meneruskan topik seterusnya, kita akan menjemput panel kedua untuk mengupas topik bertajuk pengujian 5G wireless network dan pengujian peranti muda alih 5G oleh Encik Liu Wunyin. Beliau mempunyai pengalaman kerjaya yang luas dalam industri wireless selama lebih daripada 20 tahun. Beliau menyertai Arisu pada tahun 2019 dan membantu memberi nasihat dan pandangan berharga kepada pelanggan mendapat penyelesaian ujian yang optimum terhadap teknologi terkini seperti 5G dan Wi-Fi 6. Dengan tidak membuang masa, saya serahkan kepada panel untuk mengupas topik tersebut.
To proceed to the next topic, we will invite the second panel to cover the topic titled 5G wireless network testing and 5G mobile device testing by Mr. Liu Wonyan. Mr. Liu Wonyan has extensive career experience in the wireless industry for more than 20 years. He joined Anristo in 2019 and helped provided valuable advice and insight to clients on optical test solution, including the latest technologies such as 5G and Wi-Fi 6. Without wasting time, I would like to call Mr. Liu Wonyan on 5G wireless network testing and 5G mobile device testing.
Hello, everyone. Yeah, thank you for introduction. So, without further ado, let me share my screen. Oh, sorry. I think Mr. Wong, you are still sharing your screen. I couldn't share my screen now.
How to take up the sharing? Stop sharing. Oh, I have to press the stop sharing. Okay, thank you. Done.
Okay, thank you, thank you.
Yeah.
Okay, let me share my screen. Okay, I hope everyone can see my screen now.
Yeah.
Okay. Yeah. First of all, thank you for inviting me to give this webinar topics. So I'm Wunyan. I'm the field marketing manager from Enrico Singapore. So I would like to take this opportunity to introduce some aspects in terms of the 5G network deployment and the device testing. Okay. So today my agenda will cover these topics. So I will first briefly introduce my company, Enrico, and then we will let's take a look on some 5G use cases. Then I'll go into the 5G device testing. So there are two aspects. So one is the RF performance, then another is on the user experience. Then next, we'll come to the network deployment and why do we need to protect the spectrum. And then, yeah, lastly, I will just run through what are the 5G test solution portfolio that Enrico can offer. Okay, so first of all, a brief introduction on the company. Our Enrico company has actually a very long history. Is founded in Japan in 1895 as first as a Sekisan Sha, then it's joint venture with another company, Enaka, and formed Enrico Electric at the 1931. So the Sekisan Sha is a pioneer for our wired communication testing, and then for Anaka is on the wireless communications testing. So that we cover both the wired side, yeah, for the traditional telephone line, and even the network for our 5G. Yeah, then we have the wireless portfolio as well to cover both the device as well as the base station. So in 1985, we formed as a holding as a Enrico Corporations. Then yeah, we actually celebrate 125th anniversary last year. So it has been a quite a long history for this company. And basically, this is our company profile. So our company headquarters is in Japan, Kanagawa, at Azukishi. So, and we have, of course, several offices in Japan as well as worldwide. And our CEO, Hamada, basically his message is that we Enricher contribute to a safe and secure society through measurement. So this is what we intend to contribute to the societies. Yeah, and test and measurement is our main business group, where we have covered the mobile, the network infrastructure, as well as the other electronics. The other business part is our product quality assurance, which cover the food safety and security. So, of course, 5G, we have been, in fact, one of the leader in terms of the 5G testing. So here comes some Enricher contribution in the 5G development in ASEAN particularly. So actually, we have been quite actively involved in a lot of national 5G task force and operators to provide inputs on areas to take note of when considering the spectrum deployment. Yeah. We also assist some national test houses to prepare and set up their 5G device and base station testing capability for the country regulatory testing. Of course, we also participate in the national regulators and local operators bidding for the 5G network mass rollout, yeah, in the nationwide deployment on what is needed to test when they roll out nationwide. And of course, we assist some national linked research institution and tertiary education institution to set up the 5G device test capabilities, as well as enable some research on national 5G smart city, artificial intelligence and IoT projects. So let's come to some examples. Yeah. So this is instead UTM. We have been supporting them with the 5G millimeter wave propagation research for the path loss model at the 28 gigahertz and the 38 gigahertz. So we provide them the millimeter wave signal generator as well as the receiver. So in fact, there's a YouTube from the showcasing this UTM capabilities. Yeah. And this one is in Thailand. So this is one of the leading renowned university, Chulalongkorn. So they have set up a 5G lab in the Chulalongkorn universities. So we contribute to them in setting up the 5G AI IoT testing center in the Chulalongkorn University. So this is instead our Enricher device tester MT8000, which I will briefly introduce afterwards. Yeah. So they have been setting up this center to enable to help the get the industry to come to the lab and then do some verification of the devices. And this is a recent one. This is where we help the Indonesia National Regulatory Lab, BPPT. So they are setting up their first 5G regulatory test lab, and we have done a remote training for them. So and then yeah, so they will kickstart to do the regulatory testing for every 5G devices to be sold in Indonesia. And in terms of the network deployment, so this is a field trial in Thailand. So this one similarly in Chulalongkorn University. This one will happen before the COVID situation. So everyone is not wearing a mask. So we can see we're holding a spectrum analyzer, handheld spectrum analyzer, and then with a directional antenna trying to point towards the base station antenna and then measure what are the 5G signals at the location. Yeah. Okay, with that, let me continue with the 5G use cases. So I believe most have been introduced what are the three main pillars for the 5G use cases. So they're namely the EMBB, enhanced mobile broadband, URLLC, ultra reliable and low latency communications, and then MMTC, yeah, massive machine type communications. So, and in fact, in between there are some of the devices or the ecosystem will need somewhere in between eMBB and also URLC and so on. Yeah. So I believe most have been quite familiar with that. I wouldn't go through much in depth into this. But in terms of the testing wise, so we know that for the 5G standards, we have been pretty much following the 3GPP standards. So the 3GPP standards that's first starting for the 5G is the release 15. So the release 15 is pretty much focusing on the eMBB part. So most of the testing and then the requirement and so on that define are mainly focusing on the eMBB, which is to enhance the speed of the 5G network. And sorry. And for the release 16, it will be we will be part describing on the URLLC. So this will expand the verticals of the cellular usage into other industry which traditionally have not been really been relying on the cellular part. Yeah. So actually release 16 is a very exciting releases. Then the last one, release 17, probably will be focusing on the MMTC part. Although I put it here, release 15, release 16, and release 17, but as a matter of fact, actually each of this release will have certain aspect of covering each of these features. So just that the focus of each 3GPP releases, whether it's more on the eMBB or more on the URLC, are slightly different on each release version. Yeah. So with this type of numbers of use cases, of course, we have been expecting a growing type of 5G devices. So not only the mobile phones or our tablets. So one of the expecting growing in terms of the 5G, perhaps it can be better used in the drone. Yeah. So you can do I mean, high data rate of transmission through while flying the drone. So as compared to the previous Wi-Fi, so we understand that although the Wi-Fi you can fly certain distance away, but in terms of transmitting high quality data, there are some limitation. So I think 5G is one way to complement that. Yeah. And of course, smart factory. So this will be in fact very much also to complement on what have been existing, mainly based on the Wi-Fi and so on. Of course, remote. I wouldn't say remote surgery yet. So probably just a remote consultancy and have a higher detailed information of all the necessary medical conditions to be checked remotely. Yeah. And of course, the stadium where you have a lot of crowds. So you need to basically settle the information. I mean, get the crowds to get the access to the network. Yeah, and so on. Yeah. Okay, so here's one of the examples that have been using the 5G in recent real life cases. Yeah. So this is the 5G in the Olympics Tokyo 2020, which has happened in the past few months. So one of the three major areas are 5G augmented reality experience. So this is implemented actually in the swimming pool. Yeah. So for the spectators on the site, if they wear this goggle, so actually they can, besides seeing the swimmers live, they will have the additional information display on the Google as well. Then another one is on the yacht event. So traditionally, yeah, so the spectators may be standing on the side, and then they may use the binocular to take a look to see where the competitors are around. In Tokyo, they set up a very wide TV, 5G ultra realistic communication technology to give the spectators to can view the events at even just through their naked eyes. Yeah, so they don't really need to get this binoculars to see it. And then another event is on the golfing event. So this one give a 5G multi-point live broadcast. So for those spectators who wants to follow particular players, so they can choose to follow, so or they can also change the angle of viewing the event when it is going on. So these are one of the application that has been being employed in real life, and we are expecting the coming Winter Olympics. So most likely Beijing will showcase more 5G use cases as well. So in the 5G network architecture, so yeah, so actually it is not as straightforward as in the previous LTE cases, 4G or the 3G cases. Oops, sorry, sorry, let me share my screen again. Something's not right. Yeah.
Phải có bảo anh chơi technology. Technology về
Okay, so I'm wasn't sure why there are some kind of like scratches on the screen, but okay, let me proceed. Yeah. So okay, so actually in the 5G network architecture, so actually okay, we take the LTE cases first. So the LTE is we know that we have a base station or the E node B. Then going to the core side, we have the EPC, the LTE core. So this is quite straightforward. So if we are to implement the 5G similar like this, then that will be this. We have the 5G base station, G node B. Then we have the 5G core, yeah, core side. So this will be the ideal make directly replacement of from the LTE era to the 5G. And this is also what we call the 5G standalone mode or option 2 in the network architecture. However, a lot of countries actually they have just recently invested quite a number of monies on the LTE side. So be it the base station or the core side. So if we are to all these countries or the operators to move from LTE totally to the new 5G architecture, it will be a lot of money. And I think the investment on the old LTE probably haven't really returned back the investment. So there are other options that have been proposed in the community. So I think one of the most notable is this NSA, so which we call the option 3. So what we did is that we will still reuse the existing LTE base station as well as the LTE core, but we just add on the 5G base station, the 5G antenna base station to complement the existing services. So this is the most direct ways to implement it. Yeah, or I would say the more economical way to start the 5G services. Then of course there are other variants as well, but as of now, global wise, this option 3 are the most popular, and then there are some countries are focusing now on the option 2. For instance, Singapore, given the size is not big, so the regulator and the government basically straight away push to the option 2. And also China is also leading on the option 2. Whereas the rest of the world mainly is still working on the option 3. Okay, so that gives you some of the background of the 5G use cases as well as the 5G network architecture. So now let's come to how we do the testing for the 5G devices. So I will first look into the RF performance wise. So given that the non-standalone mode NSA testing is one of the most popular architecture. So what it did is that, so the LTE side connecting to the core. So the base station here will transmit the control data, control information, and as well as carry some of the data. Then the 5G wise, when it will be added in, then they will mainly on the data transmission. So this is the NSA mode, or the so-called the ENDC. E stand for E ultra, the LTE side. Then N stand for new radio. So dual carrier. Yeah. So in the lab testing, so we will be doing similarly. So we will have the one equipment doing the LTE and the control as well as the data, and then the 5G test equipment will be doing the data. So and then in terms of the physical layers, actually there are quite a lot of difference between the LTE and versus the 5G. Yeah. So one of the uniqueness of 5G is flexibility, because this gives to support various conditions, be it the subcarrier spacing, signal bandwidth, waveform, MIMO, and so on. So take a look on the LTE. So in terms of the frequency wise, so basically it is operating, we call it sub-6, which is below 6 gigahertz. And in fact, I would say most of them are sub-3 gigahertz. Yeah. And the bandwidth are kind of like only a selected bandwidth being defined. So 1.4 meg, 3 meg, 5 meg, 10 meg, 15, and maximum 20 meg. Yeah. Although there is a carrier aggregation, but as of a single carrier, is the maximum is 20 meg. The subcarrier spacing is fixed, 15 kilohertz. Then we have the waveform from downlink and uplink is also kind of fixed. Yeah. But for the 5G, so in terms of the frequency spectrum, so actually they define sub-6 or the frequency range one FR1, and then we have the millimeter wave FR2. Actually, the FR2 is totally new to the cellular industry. And in terms of the bandwidth wise, so actually there are a lot more bandwidth, and it can go as much as 100 megahertz. So testing such a wide bandwidth is actually not an easy task. Yeah. And for the FR2 for single carrier, it can go up to 400 megahertz. Yeah. And for the subcarrier spacing wise, so actually we can have a 15 kilohertz, 13 kilohertz, 60 kilohertz for the sub-6, and the 60 and 120 kilohertz. So actually this particular subcarrier spacing actually play a very I would say it gives a lot more flexibility in terms of the network physical layer configurations, and but unfortunately it also add on a lot more complexity to the device testing. Yeah. And of course the waveform, they are slightly different. Yeah. Whether it's for a higher speed or a higher power. Yeah. So for LTE area, I would say most of the physical layer components are fixed. So the testing wise is not that difficult compared to the previous older technologies. Yeah. But for 5G, because of the so-called flexible numerology, actually it add on a lot more complexity, and it is quite difficult, yeah, to do the 5G device testing. So this is a slide showing the 5G numerology and the frame structures. For those of you who are familiar with the LTE frame structures, so you know that the one frame equals to, it has a consists of a 10 subframes and equals to 10 milliseconds. And one subframe equals to 1 millisecond. But okay, for the LTE side, it is also equals to one slot. But for 5G, I put it here n slots. Yeah. So actually n is depends on the numerology. So which is this particular mu, whether it's 0, 1, 2, 3, or in other words, what is the subcarrier spacing here? And one slot will still always equals to 14 symbols. So with this particularly numerology, so actually you could see that the frame structure, the timing for one slot is different for different subcarrier spacing. For instance, for the 15 kilohertz, which is exactly similar to the LTE, so one slot is still equals to 1 millisecond. So it is totally compatible with the LTE. But if it is a 30 kilohertz, which is very common for the spectrum using the 3.5 gigahertz, so one subframe actually equals to 2 slots, and each slot will be equals to half a millisecond. Yeah, so see the difference here. And then for 120 kilohertz, which is on the millimeter wave, so one slot will actually equals to 0.125 milliseconds. Yeah. So the timing become very critical. And FDD versus TDD. So for this duplex mode, so most of the operators, I would say, around the world probably is very familiar with FDD, beginning even from the 2G, 3G, or even the LTE. Yeah. TDD already, although it's already started since the 3G side from the China TD-SCDMA and also the TDD LTE, but I think the rest of the world not so familiar with it. But for 5G, TDD is a major adoption. Yeah. So it is widely for FDD, it is widely adopted for the legacy system, but 3DD is a preferred choice for 5G deployment, especially for the 3.5 gigahertz, the so-called the premium spectrum, and also the millimeter wave. Yeah. So we have to be familiar with on how to change from FDD to the TDD. So this gives an overview of how the benefits of using the TDD. So for TDD, actually the network operators can easily schedule whether it is a downlink heavy or an uplink heavy scheduling. Yeah. So for a downlink heavy scheduling, so what it can do is to assign more downlink symbols or downlink slots in the frame. If it is uplink heavy, for instance, if you need to from a drone or camera, surveillance camera, then you need to upload the data, high definition images, then you can schedule it to have more uplink symbols on the frame. And this is not so easy to be done under the FDD mode. Yeah. And for the RF measurements comparison between the LTE 5G FR1 and FR2. So in terms of the FR1, this is also called a sub-6 gig. So basically the precision measurement is still through conducted mode. So this is still very similar to the LTE, and the test items, as you could see, I would say most of them are quite similar to the LTE side. So for the sub-6 gig, there is I think for the industry is still relatively easy to transition from the LTE to the 5G sub-6 gig. Although, yeah, the so-called the physical side, there are quite a lot of changes, but in terms of the connection wise, yeah, this is still more or less the same. But for the millimeter wave, this is a total new challenge. So we due to the implementation of a phase array antenna in order to get the beam forming, so we can no longer rely on the RF cable itself. So we have to do it over the air and have to use a chamber, yeah. And to measure the millimeter wave over the chamber, so there are also a different kind of metrics. So for instance, you could see EIRP, TRP, BIMPE, EIS, and so on. There are a lot more measurement metrics as compared to the conductor mode. So in terms of the OTA measurements, in order to get a repeatable or accurate measurements with a good tolerances, so the industry basically we need to measure it on the far field where the waveform is at the planar waveform, yeah. So there is a formula to define where is the so-called the near field, consider the near field or the far field. So basically this is the criteria, 2D square over lambda. D is given, to be more precise, should be the antenna aperture dimensions, and then the lambda is of course the wavelength, yeah. So as you could see, as the wavelength goes smaller, which is the case for the frequency going higher in the millimeter wave, though the so-called the far field criteria distance will get much larger. And also in terms of the antenna, the dimension size, sometimes we do not know where exactly is the antenna, and then we do not know what is the location of the antenna inside the device. So we have to make an assumption it was this whole device to be the antenna aperture. So that is why for millimeter wave, in order to measure the far field, you would need a relatively longer distance as compared to the sub-6 gig here. So there are several approaches like a white box, gray box, and black box. So white box is particular for the R&D, where you are designing the device and you know the antenna size, the D1, and you know exactly where it is located in the device, so that when you do the measurement in the chamber, you can position it right at the center of the antenna location. But for a test house, you do not know exactly where the antenna is being located, you have to make an assumption that it could be anywhere in this device form factor size. So we will take this dimensions D2, and then we will need to treat it to do the OTA measurements considering these dimensions. As we remember just now, the formula 2D square over lambda. So you can see apparently D2 is much larger than the D1. So in order to get to the far field conditions, so you would, for the black box approach, you will need a much larger chamber or at least a longer distance. So this is the case for usually for conformance testing or verification or carrier acceptance testing. So they are somewhere in between gray box, where you may know the antenna dimension, but you don't know where is it exactly. So somehow you will still may need to assume this D2 for your measurements. Yeah. So for the OTA system main component, so actually there are several. First, of course, is the test equipment that is capable to generate the signal and analyze the 5G signals. Then usually we will have a converter to up convert to and the down convert from the millimeter wave. Then we have the enclosure with the chamber. So the chamber size will, of course, that is where the 2D square over lambda will determine what is the chamber size needed. Then we have the positioner, where we do the rotation in order to get the 360-degree kind of like measurements. And of course, we have the antenna probes operating at the particular frequency of interest. And finally, of course, is the measurement and control software to control the whole system. So Of course, Enricher we do provide such a system. We can have offer the either 8171A is a so-called a direct far field, which is suitable for the white box testing, and the 8172A, which is we call it CATR chamber, which is suitable for the black box testing. Later, I will come to comparison of what is the DFF and CATR. Yeah. So now take a dimension of a device of a 25 centimeter, which is about a 10-inch. So assuming your tablet, yeah. So if it is operating at the millimeter with 28 gigahertz, so the far field criteria will be 11 meter. So that is a relatively large chamber to be needed if it is to be measured like a direct far field. Yeah. So in terms of the OTA test setup as per defined by the 3GPP, so actually they have defined two types. One is DFF, direct far field, and one is so-called the indirect far field. So the direct far field is that you will have the antenna directly facing to the device. Yeah. So it is a kind of a line of sight testing. So this, given that just now we compared the direct far field need a very long distance. So that is assuming that we do not know where exactly is the device and antenna location is. So if we know exactly, then of course, given the D is smaller, then we can position it nicely just on the spot, and then we can still do a direct far field. But this is usually good for a protocol testing instead of RF testing. So for RF testings, where you need to measure parameters like EVM, spectrum emission mask, and so on. So what the 3GPP recommend is a so-called indirect far field. So which is where you have the feed antenna directing the signal and then go through the reflector just like a mirror, then you achieve the so-called the planar wave. So this gives an illustration. So we have the antenna connecting to the signal generator there. Then you have the beam towards the reflector, then illuminate towards the reflector. Then ultimately you form all the planar wave. Then by this we can actually kind of like shorten the total size of the chambers needed. So this is the basically the difference between the DFF and IFF. Yeah. So I just highlight the disadvantages. Yeah. So for the DFF, the disadvantages is that the measurement uncertainty will increase quite significantly when the antenna is not at the center of rotation. Yeah. So that's why it is only very suitable for the R&D where you know exactly where the antenna location is. And also it is not very suitable for black box testing. So it is only probably applicable for the white box testing. While the IFF in indirect far field, in particular this CATR, the OTA equipment configurations is will be more complex. Yeah, and there is a challenging to simulate the arrival of signals. Yeah, so but it is a very, you can achieve a very good uncertainty for the black box testing. So that is why for RF conformance testings, the most of the test house they will adopt this IFF test mode for the 5G device testing. So this is a comparison between the white box testing and black box testing of Enricher solutions. So here we have, you can see we are positioning the antenna right at the center. Whereas for the black box, we can just mount it, and then as long as it is within the so-called the quiet zone, then it is fine. Yeah. So this is basically how the internal looks like. Okay, that is the RF portion. So next I will come to the device user experience. So what will be the user feel about your device? So there have been several aspects that to take care. While these are the items actually is not specifically being defined under the 3GPP. So 3GPP does not really require you to achieve all these requirements. Yeah. what is your maximum throughput and so on. So however, it does impact how the user will feel when they use the devices. So the throughput testing is one aspect of it. So if you are having a 5G device, you are most likely expect that it can perform a faster download. Yeah. Then the thermal wise, yeah, how much heat is generated on your device when it's operating under a maximum throughput conditions. Yeah. Then and it is quite related to the CPU stress things. And then even when we have a higher throughput on the RF side, is the CPU capable of coping with it? Then the next is on the power consumption. So will it drain the battery significantly faster? Yeah. So these are the some of the user experience, and it is usually tied with throughput testing. So you want to condition it to the maximum throughput to in order to do all the rest of the user experience testing. So that's why from our enriched test solutions, we provide an easy ways to condition to give the maximum throughput. So there are two aspects of it. So one is the physical or the so-called the theoretical maximum max throughput. Then another is the IP throughput. This is where you're connecting to the internet servers and how the actual streaming, like for instance, if you are streaming a movie like from a Netflix, and then what is the IP throughput and so on. So we can provide to monitor the throughput graphically over time, or we can also measure specifically some of the counts of the parameters like acknowledged, not acknowledged, and the discontinued TX for further detailed analysis. Yeah. So this is an example of the throughput monitoring over time and scenario. Yeah. So this gives you like first we start with the LTE, then we add on the 5G. So we can see the max throughput comes up. Then we activate some data. So this is where the green color graph plot. Yeah, so this is the IP throughput where you have some data going through from the network to the device. Yeah, and also you can also activate some other do other changes to your device. For instance, you want to hand over of the LTE cell, or you activate the carrier aggregation, and also aggregation, and then you will see try to see what are the throughput has been behaving. Yeah. And very often now with the 5G, a lot of consumers will expect the video quality itself will be a much better experience. So if you have a very high data rate, but the video output is poor, so I think yeah, definitely the end customer may not be happy with it. So, but the video quality, there are also a lot of factors. So it may be from the source, it may be from the network, it could be on the device, the display, and so on. So how we want to do a so-called aggregated comparison on it. Yeah. So we work with our partner, Spirent, to come out with a so-called the machine learning kind of like evaluation of the video quality output on the device. We can do a streaming from the live internet of the live content. Yeah, we just use our MT8000 to simulate the 5G network. So you might think that, okay, why not we just use the 5G live network to do the testing? But sometimes 5G live network will give you a lot of uncertainties, and you might not have a good apple to apple kind of like comparisons. So, and in the lab, at least we can kind of like control what are the network condition scenarios. For instance, whether it's a normal connection, stable, or you want to simulate handover kind of like scenarios, or at a very weak signal scenarios. Yeah. So that is the good thing of testing the user experience in the lab. Besides the video, another aspect is of course the audio. And in fact, audio is defined under the 3GPP and also is required by the regulatory under the safety regulation or hack hearing aid. So there is audio quality testing is categorized by similarly mean opinion scoring testing, and then we can again we can configure whether it's a voice over NR or the fallback to voice over LTE for the testing. And then we have the mobility test use cases. So this will be kind of simulate if you're moving across different cell coverage. So maybe you move from a macro cell, then you come into a smaller cell where you have a two base station, then you can aggregate it and to give you a faster connection. Then you come to the 5G network, then you will add on the so-called the ENDC mode or the 5G NSA mode. Then how we upload it, So we can do all this kind of testing, and it's especially good for the regression testing, or if you are a software developer, so you want to check whether it is stable when your device is going across different mobile coverage. So as a summary, so for the device user experience testing, so here are some of the features that you could cover using our enriched MT8000 with the so-called SSNR. So just now I mentioned about video quality, voice over NR audio quality, mobilities, and actually it could also cover like earthquake, tsunami warning system, multi-SIM network slicing, battery consumption, throughput, and the IMS messaging as well. Okay, so that's the device testing. So now I come to the network deployment side. So for when you deploy the 5G network, so you just for the operator side, they definitely have a business motivation to protect it from being interfered, by whether it's intentionally or unintentionally, because operator have been paying a lot of money in order to get the spectrum. So, but meanwhile we also see that when in certain country when they do the 5G rollout across the country, there is a potential you may face some protest from certain public groups. This happens in the Western world, but even right at our side in Singapore, I do hear that there is some certain area when they try to set up the base station, 5G base station, there have been some I would say some groups come up and then voice up their concerns. So this is I will talk more about that later. So in that you need some transparency and also the continuous monitor and collect the measurements data of the so-called the EMF, the electromagnetic field to the public, so that you can proactively and then preemptive, so that to kind of like educate the public that whether it is safe or it is within the limit that is being set internationally. So these are a few items to be considered from the business motivation side. Then of course the technical reasons. So the 5G implementation, such as the massive MIMO, beamforming, and has been caused some conventional measurement methods no longer suitable or applicable. And due to the higher operating frequency, so some of the it could be a bit vulnerable to the interference, and also they have a higher path loss nature. So when it has some interference that could be really cause some distortion in the operations. Then most of the time operators will be only keen on only try to map out the coverage areas. But however, we found that actually it is also essential to monitor for any hotspots that some RF energy is interfering with the 5G signals. Yeah. So if you have spotted it, then it have to be worked out to track and identify the interference source and clear it off. And somehow the challenge is that the interference can be intermittent. It is not always there, so it will be quite difficult to find. Yeah, using some conventional tools. So some new tools that need a large enough bandwidth, long enough duration of data capturing, high speed, and so on will be the more effective ways to capture this unusual signal that could cause the interference. Yeah. So yeah, so in terms of the 5G measurement key parameters, of course, when you first deploy, yeah, so probably the signal coverage, which I think not only the 5G, so the 3G LTE era, so it has been done. So this is nothing new. The basic parameters according to 3PP, so probably this will be done as well. So like unwanted emission modulation analysis, but and then here occurs some of the items that has been quite often being neglected. Yeah, so the transmitter power, EIRP, EMF, and the interference monitor and hunting. So I will dwell more particularly on these areas. So first, the EIRP. So what is the EIRP? So we know that from antenna, for instance, if I input a 1 watt, then I measured it 100 meter. If I use a equipment to measure it, I may get a minus 42 dBm, and it would be kind of like no matter which direction that I measure, it would be the same as long as the distance are same as 100 meter. However, if I make my antenna to be directional, so for instance, I make it point towards this particular point, and if I measure it 100 meters from the antenna, I may get a higher power. So even though the input power is still the same 1 watt and the same distance 100 meter, so I seems to get a higher power. But this is what it really does is just that it direct some of the energy focusing on certain directional. So this is the concept, basically the concept behind the EIRP here. So why we need to do the EIRP test for 5G base station? So before the 5G, so the radio unit and the antenna basically are separate. So the antenna port quantity are lesser. So if we can do the conducted mode measurements and then we get the antenna gain and then you get the distance, basically we can calculate that, yeah, or at least estimate it. But for 5G, we have been implementing the massive MIMO. So, and the RRU maybe integrate together with antenna array, and especially for FR2, yeah. So basically, the only method to measure the power output from the base station is basically just over the air mode, and you can't really use the conductor mode. So, and out when you are deployed your base station in the field, so the EIRP is the probably only way to know the emission power of the G node B. Yeah, and of course, and we should do come with this our equipment to specialize on how to do the EIRP. Yeah, so here are some of the base station type. So and also so we basically have a conductor type, a hybrid type, over the air type, and also this is for the FR2. Yeah. So there are different type of the 5G base station. So how to make a EIRP test in the field? So I just put it up in a quite simplified manner. So one is that you obtain some key parameters from the equipment side. For instance, the receiving antenna, this particular horn antenna, which is directional. you want to know the gain, and then you have a cable connecting to the analyzer. So this will be we need to know the cable loss. Then the position from the antenna to the base station. So we need to do a measurement of this distance. So for this, we can use some kind of like and you know the golfer sometimes they have an equipment to measure the distance, yeah, laser pointer and so on. So it is able to do that. Then if there is a switch to switch between the horizontal and vertical, so the switch response, we will need to know that. So this is the switch response, yeah. So in order to measure the EIRP, we need to measure two polarization, so horizontal and vertical, yeah. So once maybe you start with the horizontal first. After that, you make a 90-degree rotation to change to the vertical and then measure it again. So actually, the most difficult part actually is to plan and then look for a suitable location and the good timing to do the measurements. So for instance, you want to maybe climb up to a rooftop, and then where you have a clear propagation path to the base station, and then also you have to be a fine weather, yeah. So actually these are more difficult part to get a good measurements, yeah. So but one good thing is that our average Field Master Pro actually it allows to do the EIRP measurement on the spot without the need of post processing, which means that when we set up over here, you can already directly get the measurement after you key in all the information directly on this equipment. So unlike others, so that they may need to go back and then to put in into the computer and then to calculate again, yeah. Okay, so the first part is on the EIRP. So the second part is on the EMF. So this could be something quite interesting as well. So EMF is electromagnetic spectrum. So I believe we all know that, yeah. So a lot of the radio actually are basically behaving in a it just have a radio kind of like behavior, but it has a different frequency. That's therefore they has a different wavelength, yeah. And the different radio frequency, they can serve different purpose. So for instance, for the communication wise, from the radio, AM, FM radio, then we have the TV, then now we have the cellular phone, then radar and so on. And for a higher higher frequency, we have the for medical use like X-ray or the gamma rays and so on. So actually we know that exposing to the very high frequency, it is actually can be hazardous to health, yeah. So that's why there is a term called the ionizing spectrum. So we try to limit our exposure to this kind of frequency sources. But for the so-called the other spectrum, yeah, so the non-ionizing spectrum, it is quite widely used for communication purposes. But because of the perception that exposing to high frequency radio would be not good for the health, so when 5G comes, especially when 5G is talking about millimeter wave transmission, so there are a lot of misconception about 5G will be hazardous to health, yeah. So that is why in certain countries there are a lot of there are some protests on rolling out the 5G, yeah. So here are some examples, yeah. So the public concern over the RF radiations. So for instance, this when when the operator try to set up the 5G base station near a kindergarten or a elementary school, so the parents actually come up and then they protest and they want this cell tower to be removed because they concern that long hour of exposure of this 5G radiation to the kids is not good for them. Yeah. So, but there are no proof on this. Yeah. So, in fact, there is a so-called the International Commission on Non-Ionizing Radiation Protection, ICNIRP. They have been published on the guidelines for the safety limits. Yeah. So basically, the limits are in a power density, and there are two sets of it. One is so-called the general public, and another is the occupational. So the general public are for users like by you and me. So we will be exposing to the public base station radiation for a quite extended periods of time. But of course, the radiation signal that we are exposed to usually is very, very weak and well below the safety limits. Yeah. And occupational are for those who needs to do the maintenance and get close to the base station for certain time period, a relatively short period of time. So they may need to monitor that how long that they are exposed to a higher power when they do the maintenance. Yeah. So here are a general overview of the ICNIRP standard. So you can see the general public, because of exposing to for a longer time, so the limit will be tighter than the occupational. Yeah. So for EMF measurements, so for enricher, yeah, so basically with the same master probe equipment, we just plug in a different kind of a probe, and we can measure whether it's for the sub-6 gig or the millimeter wave EMF. Yeah. And this is an example of doing the measurement for general public EMF. So in a public area, so where you have the probably just a newly deployed 5G base station around, where you have a 5G signal around, so we will bring the equipment around, then set up the tripod, and then with the probe connecting to the analyzer, then you adjust the height of this probe. Yeah. So we want to measure what will the exposure to for instance, from an adult, then to a teenagers, then to a kids. So you will adjust the height of this probe at one spot, then you move to another spot, and then you measure again. Yeah. So this is one way to collect the so-called the general public EMF measurements, especially on the site where you would deploy the new 5G base station. Then for the occupational, so yeah, so just to give you an example, in the US, actually the FCC, they put up that it has to be a warning sign that one this will be a high power radiation area, and the general public should not access this area without permit. So for those technicians, when it comes, so for this is a site where you can see there are two new millimeter wave base station. So here the technician will do the measurement of the EMF. So of course they will have already collected the EMF for the legacy radio first. Then when the 5G new radio being deployed, then they will collect again and see what is the impact of the newly added base station. Yeah. Of course, they have to work around on this the yellow colored box area, and then try to avoid to walk into the red color. So usually the red color is for maintenance purpose, not for the measurement purpose. Yeah. Okay, so I think here comes the last portion on the deployment is on the monitoring the interference. Yeah. So there are a lot of sources of interference. So we have a random source, or intentionally, or due to the unlicensed or changing bands. Yeah. So sometimes it is difficult to prevent. So you will still need to on and off do the monitoring. Yeah. So this is an example of a random interference. So actually in this village, uh, the villagers have been complaining that um, the the signal are kind of like very poor after certain hours. Yeah. So but the operators have been trying to debug it from their side, and they did not see any issues from their configurations. So they sent some people to the village, and then finally with the so-called the spectrum analyzer, then they walk up and down, then they pick up a signal at the certain hours at the 7 a.m. Yeah, so pick up a very large burst of electrical interference. So actually this is one of the villager who turned on the very old TV, and actually it kind of like knocks out the broadband of the entire village. Yeah. And another example of intentional interference is that, yeah, so some in a shopping center, so there have been complaints that the reception is very poor, the network performance is very poor, and it was only an issue during the daytime. So when they further try to find out, so actually it found out there is a LTE jammer bought online, and then they is being operated illegally. So when they found the so-called the store owner, actually they set up this LTE jammer to keep the employees off their phones during work hours. Yeah. And then another example, it could be due to the change of bands. So actually, yeah, the new 5G allocation band, for instance, they announces the new 600 megahertz. So by getting to this new spectrum for cellular, so some of the old electrical system that have been operating at the 600 megahertz, so they will need to be kind of like move out of it in order to get the new this new cellular 5G 600 megahertz operate without interference. So, and for a country as big as in the US, it may be not easy to really find out. So that's why at every single location, they need to do that will deploy the 600 megahertz. They will need to kind of like monitor the spectrum to ensure that, yeah, the old system is not operating, and then so that it wouldn't interfere with the new spectrum for cellular. Yeah. Okay, so now comes to the mitigations. So there are three typical stages of mitigation. So the very first step is so-called the spectrum monitoring or the clearing. Then the second step is the identification. Then the last step is that if you found one, then you know you need to hunt it down. So for spectrum clearing or monitoring, so this is the first round of information. So we want to check in terms of timing, locations, frequency, and so on, whether there are any spectrum occurs. Yeah. So this is the basis. Yeah. So you can use a spectrum analyzer, and then with some limit, and as long as it's we will expect a lot of noises and randomly. So as long as it does not trigger and then the threshold of the limit, so it should be fine. So what if it detected some interference? So now you would probably need to capture it. So because the interference could be intermittent and it could be happen very fast. So if we are just to send people to take a look on it, it may not really capture it. So we may need some system to capture all the data, then you do a post processing, and then to find out a clue what could be the signal type, and then what frequency it is happening, and how frequent it is happening. Yeah. So that's why capturing and then signal playback and then digitize it and then to do the analysis. And in terms of the, if you really identify one, so this is the final step in removal. So you need to find out where is this interference sources is being hidden. So you can probably drive around and then to zoom down, to nail down the hotspot, and then when you're closer to it, then maybe you can start to walk around, and then with so-called the antenna and with a kind of like beeping sound, then you can find the exact location of giving this interference. So probably by giving you some example will give you a better idea here. So this is a first case in the United States. So yeah, as mentioned, there's a chip repeater has been purchased online. So this is one of the customer. He wants the better cell signal at his premises. So he purchased a repeater online. But due to the poor filtering in the repeater itself, so it actually leaked to other carriers. So if use a normal spectrum analyzer, so because the signal is sporadic, so it may not be easy to track it. Yeah. But with a so-called the new tool, we call it a RTSA, a real-time spectrum analyzer, as you could see something like this. So this is slightly different from what we usually see using the normal spectrum analyzer. So actually we can kind of like detect besides the frequency, and then you might also know that how frequent does this happen, and then then you will find it easier compared to the spectrum analyzer, normal spectrum analyzer. The second case is actually happening in China. Instead, I could share with you that we have we have seen quite a lot of interference happening in the China due to the on their new 5G deployed network. So this is in a metropolitan area. So they have been complained that there is a major interference, of course. So here using the RTSA again with the spectrograph and so on, so we can kind of determine the signal fingerprint, yeah, to identify. Okay, then slowly floor by floor, then to try to search, then we finally identify that there is a unit at install a power booster. So yeah, so actually this is the source of the so-called the peak, and then that interfere with the 5G operating system. Another case is the on the 5G and versus the weather satellite. So this time around is not 5G being a victim, but 5G is kind of like cause the satellite some interference to the satellite reception. Yeah. So the new 5G spectrum is allocated adjacent to a satellite downlink, which is at 3.7 to 4 gigahertz. Yeah. So when it is operating, the 5G operating at the 3.45 gigahertz, but it's out of band emissions actually fall into the spectrum of the satellite Earth station, and it does interfere to the Earth satellite. So by using our, again, similar our tools, that we prove that, yeah, this is something that from the base station, then of course the base station, the operator need to do some tweaking so that to move optimize it so that it doesn't interfere with the satellite. Yeah. And the last use case is the amusement park. So because of the needs for all these maintenance and so on, so actually they will need to manage the communication between the staff and also the the gaming the facilities. So in order to ensure the safety of it, so if interference do happen purposely interfere, they could cause a major safety concerns. So some of the famous amusement park actually they purchase our equipment in order to monitor the frequency and hunt for interference. Yeah. So this is also one of the use case. Okay, so this is an overview of one of our equipment, MS2090A, the Fieldmaster Pro, which is a handheld spectrum analyzer. So it have this RTSA real-time spectrum analyzer mode, which is very good for some initial preliminary checking for the interference. Yeah. And then data sweep will be probably particularly good for a TDD kind of a signal analysis. And of course, it will have the 5G cell analysis, so which is good for deployment for the check. Then it does have the near mapper to kind of like map out what is the coverage signal levels, and the EIRP, as I mentioned first, and the EMF. So it will measure the field, electromagnetic field strength. Yeah. So basically, all these functions can be used in one single equipment, so it can serve multiple purposes. Okay, I think the last part will be just to briefly share our Enriser 5G test solution portfolio. So the first time is on the device testing. So just now I have what I've mainly shared is on the signaling tester, the MT8000A, where we simulate the 5G base station. So we will be good for the device testing, and it works with the so-called the LTE anchor for the NSA mode. Yeah, and of course the chamber for the millimeter wave testing. But for component levels, we do offer our vector network analyzer as well, capable of up to 220 gigahertz, or even then a signal generator, signal analyzer with a high bandwidth 1 gigahertz analysis bandwidth for the component or the transmitter level kind of a testing. And certification wise, actually we are this is one of our Enriser pride, where we are really leading in terms of the RF conformance testing for 5G. So we have our ME7873NR for the RF testing and the protocol testing for the ME7834. And for production test, we also have the MT8870A, which is optimum for a mass volume and to bring down the cost of the testing. Yeah. And of course, for the commercial, this is where the user interface, user experience testing. We offer the same MT8000A hardware, but a different software for the application test. And actually, we are not as only covering the RF side. Yeah, so actually we also covering the wired side. So just now I mentioned about the MS2090A. This is the for the RF wireless testing for the base station and so on when you deploy to the field. But we also have the so-called the network master to do the mobile front haul network transport testing for the cable side, for the fiber and so on. So basically, we do cover from both the wireless and the wired. So welcome to visit our webpage for more information. So we have a dedicated page for a 5G. So you can visit and then take a look on what are the aspects to be tested. Yeah. And last one is that we do have a website, a virtual exhibition of our Mobile World Congress 2021, which is happened earlier this year. But even though the event has been over, I think we can still visit and take a look. So in the event, actually, we share about some of the topics like a terahertz technology for beyond 5G, and then smart factory, network slicing, and so on. So yeah, you can feel free to visit this website to take a look on our virtual exhibition. Yeah, this is not a permanent website, so it may be bring down maybe next year after the Mobile World Congress. Yeah, 2022. So okay, that's all I have. Thank you for listening. So I'll stop my sharing.
Mr. Liu Wonyan,
Yes.
we have a question from the chat room from Mr. Muhammad Azlan.
Okay, let me take a look here. Okay, there's a question about already have a analyzer model MS2720. So is this model can use to test and check all parameters of 5G at site, including field strength, 5G parameter on antenna. Okay, unfortunately, yeah, so for the demodulation of the 5G signals, especially the so-called the SSB, the synchronization signals, this is not built into the MS2720 yet. So is for the 5G function is mainly on the model MS2090 that I mentioned just now. Okay, so let me see. Okay, there's actually another question. Is Malaysia ready for transition to 5G? Okay, yeah, I do hope that, yeah, Malaysia will be ready to transition to 5G as soon as possible, because I think take a look on the situation in ASEAN. So the very first country to deploy 5G commercially is Thailand, then followed by Singapore, then Philippines, and Indonesia has also launched 5G just I think last month or in September. Yeah. So a lot more country in ASEAN has been already deployed the 5G commercially. So I hope Malaysia can really speed up. I think the infrastructure wise, I think should be quite readily deployed. So probably the hard part is probably is more on the policy. So yeah. So that is the part that well, it's difficult to control. Yeah, from the yeah. Okay. Yeah. So far. Okay. Any other question? Anyway, yeah. If you have any further question, yeah, feel free to drop us an email to our and then we are delighted to help you. Yeah. So because we have been in ASEAN country, we have been quite actively working with whether it's regulators or the operators to deploy the 5G.
Terima kasih kepada Encik Liu Wenyin sebentar tadi. Banyak ilmu yang dikongsikan mengenai pengujian 5G wireless dan pengujian peranti mudah alih 5G. Para peserta diminta untuk mengisi borang kaji selidik bagi webinar 5G di ruangan chat dan WhatsApp bagi penambahbaikan untuk masa akan datang.
Thank you to Mr. Liu Wanyan just now. A lot of knowledgeable is shared about 5G wireless network testing and 5G mobile device testing. To all the participants, please fill up 5G survey form in the chat and WhatsApp.
Para peserta sekalian, program pada hari ini diharapkan dapat memberi kesedaran dan pemahaman mengenai kepentingan teknologi 5G kepada masyarakat serta peluang-peluang pekerjaan yang terbina apabila dilancarkan kelak. Bagi pihak institut, kami mengucapkan terima kasih. Jutaan terima kasih kepada penceramah kita pada hari ini iaitu Encik C.Y. Wong dan Encik Liu Wenyin. Tidak lupa juga kepada semua peserta yang menyertai webinar pada kali ini. Sampai di sini saja perkongsian ilmu pada hari ini sehingga kita berjumpa lagi di lain waktu. Terima kasih.
Ladies and gentlemen, today's program is hoped to provide awareness and understanding on the importance of 5G technology to community as well as the career opportunities that will be built when it is launched. On behalf of the Institute, we would like to say a million thank you to our panel, Mr. C.Y. Wong and Mr. Liu Wanyan. To all the participants who participate in the webinar this time, up to here, only the sharing of knowledgeable today until we meet again at another time. Thank you.
Okay, thank you. Okay, thank you.